This AI system has resolved over 1 million support cases at Cisco. And today, we are talking to the 2 engineers who built it. Hi, everyone. I'm Apurva, and this is People Who Ship, a series that brings you real-world stories from people building and shipping AI applications into production with MongoDB. Scaling generative AI in production, that's a tough one. But our guests today have clearly cracked the code. Joining me today are Shawn Roberts and Mohammed Hamz from Cisco, who are here to share exactly how they did it. So, hi, Shawn, and hi, Mo. Welcome to People Who Ship.
Hey,
Hey, thanks for having us.
All right, let's jump right in. Let's start with a quick round of intros. So, Shawn and Mo, why don't you tell us a little bit about what you do at Cisco?
Oh, hello, everybody. My name is Shawn Roberts. I'm a distinguished engineer in our CX engineering area. I do a lot of things around innovation, automation, platform creation, generative AI. Like to get at Cisco Live and like to meet a lot of our customers, all with a goal of continuing to drive a superior customer experience for you guys, our customers, and hopefully Mongo customers as well.
How about you, Mo?
hey everyone. My name is Mohammed Hamz. Everyone calls me Mo. I am a principal engineer in CX engineering, so the same org as Shawn. And mainly I do generative AI and automation work nowadays. So that's kind of my primary role is to build generative AI solutions with automation to help our tech engineers and augment them while they're doing their job, give them capabilities that help them solve cases faster, solve cases better.
Awesome. Love to hear that. Just for folks who are not familiar with the term TAC, can we just set the uh, stage for what that means?
Yeah, sure. I mean, TAC is Technical Assistance Center. It's the part of Cisco customer experience, which is responsible for receiving and handling customer service requests, support calls, ticketing issues, and escalations. It's TAC itself is a very interesting support center because it is not really a call center in a traditional form, right?
Okay.
So TAC is really more of an engineering center, and it's really all about our customers. Our customers are not just regular consumers and users of technology, they are expert engineers. A lot of our customers are CCIE level engineers. They come in and they bring in a lot of expertise and they bring in a lot of complicated issues. So the nature of the problems that we get in tech requires the organization and requires the engineers that are handling those types of problems to be at a very high technical level. So it's a support center, but it's a very highly technical support center.
All right, cool. I didn't know what TAC was, so this is really helpful background for me. And yeah, I hear that you built basically your first virtual TAC engineer at Cisco. So for today's episode, I want to focus around how you went about building that. I hear you've solved upwards of 1 million cases, which is the kind of scale we don't hear frequently when it comes to Gen AI, at least right now. So really excited for this one. So let's jump right in. Let's start with some numbers. Can you tell me, in terms of scale or reduction cost or whatever metric you deem important at Cisco, some of your biggest wins with generative AI?
Sure. So if you look at the virtual attack engineer as a whole, as Mo mentioned, the goal was to make lives easier for our attack engineers. So we saw an issue in that, as most support organizations do, TAC runs at very good margins, right? We like metrics, like we like how many cases did you solve, or how good were the cases solved, and those kind of things. And we use that, as most support organizations do, to create staffing models and things like that. So, what does that mean? That means that you're running razor thin when it comes to staffing, and it's really hard, not impossible, but very hard to handle avalanches of cases, right? Some major event
Mm.
happens, like Log4j, right? Some major event happens in industry, and now you've got tens of thousands of cases coming in, and well, that means some customer's going to suffer because normal support organizations aren't equipped to handle that. So we saw that as an opportunity to be able to create a virtual attack engineer that could provide expansive capabilities as scaling of humans, as well as be able to provide us great ROI. And I'll talk about a couple metrics, and then Mo can dive
Mhm.
into the generative AI component.
Sure.
So a couple items, as you mentioned, we did cross 1 million cases back in December of 2024, which was huge. On an average, the virtual attack engineer is working 3 to 4,000 of its own cases per day and is
Wow.
collaborating on another 20,000 with other attack engineers throughout the organization, helping them move the cases along or watching the cases while they're on PTO or something to that nature. On the daily, and Mo will check me on this, but I think we look at and review some words of 130 to 140,000 cases are reviewed on a pretty much regular daily basis. So we're looking to just continue to scale, and we're looking to, add new features, add new capabilities to the virtual attack engineer, because that's going to allow it to continue to scale. Pass it off to Mo to talk about some generative AI fun.
When our virtual tech engineer was first conceived, there wasn't like generative AI wasn't really a thing.
Yeah, this was what, 2019, right?
2019. Um, so it was primarily using machine learning models,
Hmm.
multiple machine learning models, classification models, regression models inside it, along with a whole lot of rules and systems to kind of control and dictate how it works, right? And fast forward to right now, that entire system is now augmented with generative AI in several different places. Our
Okay.
traditional machine learning models were replaced with zero shot generative AI classification models. Our ability to detect case updates, update cases, generate summaries for our cases were now all moved from static templates into generative AI generated summaries. So the virtual engineer is now capable at figuring out the right status, updating the cases that it works on properly, adding more human like documentation and better documenting its work. In terms of responding to the customer, helping tech engineers, and performing follow ups while augmenting engineers, we used to use templates. Now it's pretty much using generative AI to help follow up on cases and help tech engineer follow up on cases. What's really cool, and all of that is cool, all of that is just
Yeah.
upgrading what we have
Hmm.
using generative AI, which
Right.
increased our accuracy, increased the ability for documentation. But there were some problems with the system that the system couldn't really handle. There
Hmm.
is just simply problems that are not deterministic in nature,
Yeah.
where the troubleshooting path and the troubleshooting flow is complicated.
Can
It doesn't.
you give me an example?
Well, not every customer is the same
Right.
in terms of communication. We're all humans, right?
Yeah.
So, an example on this: a customer might complain about a certain log message, right?
Hmm.
So they might put the log message in place inside the service request at um, when the case was opened, right? And they say, all right, what is this log message? Uh, an engineer, a flow for that could be, hey, I need to search the internet, look at the log message and see if there's any documentation. I need to look at historical case data to see, did it appear in previous customer messages? Do I have an internal knowledge based article that talks about this? Or
Yeah.
do I need to actually look at the customer configuration to see, is it related to an existing configuration or not? So
Hmm.
that type of troubleshooting path is a little bit more stochastic. It's not really a deterministic troubleshooting path. You have
Right.
to kind of decide and look into multiple places and decide what to do based on the problem description that you're given. Maybe
Hmm.
you search on the internet, like in Cisco.com documentation, and you find it, or you
Right.
find it in a historical case, or maybe you need to ask for an output. So
Yeah.
that's kind of the level of problems that the traditional approach of rule based couldn't really handle very
Hmm.
well. You
Yeah.
have like there's really complex decision making that needs to happen.
Right.
Now with generative AI, we kind of upgraded the core system using AI agents and agentic flow.
Yeah, that's what I was going to ask. Okay.
It is an AI agent that
Hmm.
runs in the background. It's actually several AI agents, multiple flavors of these AI agents. They're more configurable. And it's a multi-agent system right now that actually looks at the problem. It can call other sub-agents. It can perform Google search on Cisco.com, read internal resources, search historical cases, and look at historical root cause analyses that might match that particular issue. It can analyze and parse through tech support data that gets uploaded.
Very
Um,
cool.
yeah, it's really weird when you see it, like just looking inside the case, looking inside the file, parsing and extracting commands on its own, figuring out what to parse. It's a bit weird as well.
Yeah, it just feels a bit like magic, huh?
It's a bit like it feels like a bit more like a robot
Okay.
doing a human job.
So, Mo, can you go a bit deeper on the architecture of that multi-agent system? You did mention it's a multi-agent system, but we see a bunch of different architectures for these kind of systems out in the wild. There's like orchestrators, supervisor, network of agents, or like custom implementation. So, yeah, could you talk a bit about that and maybe some of the main features of what each agent does or the system does as a whole?
Sure. The main architecture we're using for this is an orchestrator agent with sub tools and sub agents as tools,
Okay.
and it's basically a collection of customizable, configurable agents that can be customized and configured based on different problem spaces. So you can come in with a different system prompt, tools for wireless versus security versus another technology. Um, and we do run provide our consumers, the people who are building these automations to solve cases with out of the box set of tools like searching the internet, parsing and agents to parse files, a researcher agent that can search internally. We also use Mongo a lot for it's our primary place where we store all our vector databases, where we store all our knowledge base, root causes analyses are all stored in there. So it's a massive store for us for knowledge, and we primarily leverage that inside the agent as well. We started actually experimenting with it, Shawn and myself, before OpenAI had function calling
Yeah.
released.
So
Uh,
were you just doing all this in just pure Python or what language are you using?
we're not using a programming. Well, eventually there is Python in the backend uh,
Hmm.
with our custom framework inside it, but it's all running in a very cool low to no code orchestration platform that
Okay.
we built, which internally we call Ascension. It's a
Oh, wow.
version of a customer facing product called XDR. So Shawn is the lead for that project, so he can tell you more about what Ascension is and how it works.
Yeah, so it's as Mo mentioned, it's our loader no code platform that runs inside of Cisco. And went live in August of 2022, I think it is now. But after we worked virtual track engineer on a handful of different, loader no code platforms until we finally settled with the Ascension platform, and we've been building since then. We've had a great this last year. We're up upwards over 88 tenants and 1,400 plus users internally. So it's really great. And at its core, running virtual tack engineer is just another core piece that it does. But yeah, to Mo's point, it allows us to, as a core team, kind of deliver some really cool feature functionality to not only the virtual tack engineer, but to other tack engineers who want to build really cool things, so they can drag and drop, different generative AI calls and things like that, and it makes things a lot easier for them.
Interesting. I'm actually very surprised that such a sophisticated system is backed by a low or no code platform, because my perception was that no code or low code platforms wouldn't give you as much flexibility to customize things as you might need to build complex systems. But uh, how was your experience with a low no code system?
For us, it's been quite great. I mean, I have a lot of experience personally. I background in computer science, and so I've writing code for years. So yeah, I could go and code things in Python very easily. But what we found is that when you categorize a part of what low no code's really good at, which is we like to call it robotic process automation or RPA, it's basically replicating what a human would do, right? So I can sit down on a canvas and I can say, okay, when we're writing the core engine, we're writing the main part of TAC engineer, virtual TAC engineer. What would I do as a TAC engineer, right? Mo and I both spent many years as TAC engineers, both working cases, both getting pretty good customer scores. So we kind of knew what to expect and what we would expect as customers. So if we could replicate that in, again, in kind of like a business logic flow, drag and drop flow, well, then great. And that virtual TAC engineer is going to provide that same premium experience to our customers every single case that's worked. So it just kind of, fit that model. And once you get into it, once you realize, oh man, I can develop and I don't have to worry about syntax, right? And I can just drag and drop and I can be done in a hurry. My efficiency can increase 20, 25%, right? And we know nowadays, every little bit helps, right? So we want to squeeze every bit of ROI out of that onion. So, that's kind of uh, why we got to. But sure, I mean, there's a lot of different languages, a lot of different possibilities out there. But we felt with the combination of having a support organization, so a BU that was very very close to us, right? So we could go get support immediately. That plus just the design of virtual tech engineer, it all just kind of fit.
So is it kind of like you're using Ascension to create like the DAG for your virtual tech engineer, but you still need to write the code for what each of those components do, right?
Not necessarily. Um, the component, a lot of the components that we use are pre-built.
Oh, I see. Okay.
So, like making HTTP requests, that's already in place. Mongo activities, like querying Mongo, that's already pre-built. There is a lot of stuff that is out of the box. There is a Python activity that you can put in there and write code in it, but majority of the things that we do are activities that are pre-built, ready out of the box to drag and drop and put it in
Got
there
it.
and then configure without actually writing code. A lot of the things that are one of the things that we've done within CX is we build a lot of those components. We build a lot of custom components like that inside.
Right. Okay. So that other solutions could kind of
So
leverage
we
them.
can use it, and other
Yeah.
solutions can use it, right?
Makes sense.
So
Okay. I'm also curious how you landed on this multi-agent architecture, right? So from in 2019, where you were running classic or traditional machine learning models to ending up at a multi-agent system. Can you discuss some of those like key factors that influence some of the more significant changes to the architecture?
it's honestly, I think the main factor that we were aiming for is increase accuracy and increase autonomy. That's pretty much the main goal since using machine learning models up to today. So, how can we build the system to make it more accurate and to make it run with the least amount of human oversight or human in the middle, while also giving high quality, accurate, correct responses? That's kind of the main goal and the main objective that drive this architecture. It started off with one machine learning model that was built using a neural network to a model that was trained on 60,000 different samples. We went to a dual model architecture where they both have to talk to each other and agree on a certain answer. We landed on a single an agent with a single activity, now at a multi-agent. And more recently, it kind of morphed into a multi-agent system that runs several sub-agents and several tools, and a supervisor, evaluator slash validator agent that actually looks at what this guy has done, what the main agent has done, what tools it called, what reasoning it made. So it actually looks at the agent internal thinking process and evaluate how it came to the answer. Then pretty much either say, go ahead, your answer looks good, your thought process is correct, or it sends it feedback and tells it, no, your thought process was incorrect. You need to modify what you've done and generate a better answer. So accuracy and autonomy are the main drivers to achieve this.
That makes perfect sense. I'm curious if you saw any regressions in accuracy by replacing some of these like uh, specifically trained ML models with an LLM or LLM based components.
Not necessarily. Um, we've been using, we've seen that in a couple of instances, but not with the most recent LLMs. I've seen this when we try to train neural networks versus classical machine learning models. And I was surprised to see that we had a regression in performance with a neural net versus a legacy. And when I'm talking a neural net, I'm not saying an LLM. I'm talking about a neural network classifier versus a regression model. Uh, so we saw a regression there. But with generative AI, we've been kind of, the way we've been doing things is we've been using the biggest available model to us, measuring its performance at that level, and then trying out a smaller model and comparing and seeing, well, how do they perform? And that approach until now, like depending on the use case, we try to use the biggest, baddest model that we can get our hands on. And we've seen the performance actually increase with every iteration that we get. Like every generation of these new models that comes out, it's just significantly better than the ones before.
Interesting. I was just trying to test out my hypothesis that a model that's specifically trained on your data might just be better than even a large model that's trained on anything and everything. But
Yeah.
okay, it's interesting to hear that that's not the case, at least with the most recent LLMs. I think for the rest of the time, I want to focus this conversation on like the scaling aspect of the system on different fronts, right? So I guess the first thing I want to talk about is like just what was your biggest infrastructure bottleneck when it came to scaling the system from, say, a few hundred to now a million support cases? And yeah, how did you go about solving that bottleneck or bottlenecks?
Well, I have a couple, and then I'll let Mo chime in as well.
Yeah,
So the first one I think for us was the power of parallelism and the power of asynchronous work, right? So when we first started out, when we first wrote the core engine, uh, to your point, we were handling, I don't know, a dozen cases. I mean, it was just minute scale, right? And sure, everything can be synchronous, everything can be in order, and no issue. Well, the moment you hundreds of cases, 200 cases, 1,000 cases, now all your workflows, all your programs that are running, that are doing certain things, are just taking too long because you're doing everything synchronously. So we made a very concerted effort early on to do everything that we could. If something was thread safe, if something could be done at the same time, the virtual attack engineer could write a log message while writing a note to a case, while sending an email, while publishing some data, right? He could do these things all asynchronously because it didn't really matter. At the same time, if we needed to say strike cases, so as a policy in Cisco, if a customer doesn't respond, we can three strike a case. We can ask the customer to get with us, or we can close it. If you can run that all at the same time, right? It doesn't have to be. Also, I could be reviewing hundreds of cases at once for this strike policy instead of reviewing just one at a time. So that helped us scale, immensely. The other thing that I'm going to mention, and not on a Mongo podcast and all, but to be quite honest, our move from a relational database to Mongo as our backend allowed us to scale immensely. That was actually an issue we were running into early on, was the relational database, and it just locks and just wasn't scaling with what we needed from just a pure throughput standpoint. So we made the decision after we had gotten in touch with y'all, and after we gotten online with Atlas, we made the decision to basically be a full Atlas implementation. And so we took Virtual Task Engineer's database or cache, put that onto Mongo. Ascension as itself runs with as a Mongo backing. And also, our team is very API centric. So we built an entire API set for Virtual Task Engineer. So our internal task engineers could, query things and whatnot. All of that, everything we do pretty much now is backed by Mongo. And I think those things in themselves really helped us scale quite a bit. So those are just a couple off the top of my head.
The most interesting one is like code optimization. Um, that was like you're writing something, you're putting logs, or you're writing a certain logic for a certain amount of, and it works perfectly fine. But as soon as you start hitting scale, you start seeing problems. You're either doing too much logging, you're doing too much iterations in a certain place. That wasn't really a problem, but once you introduce 10 times the load,
Yeah,
that entire area of your code just
everything
blows
starts
up.
to hurt a little bit.
Yes, and everything starts backing up and exploding. So as we are building through this, we identify these areas of optimization that some code needs to be refactored, rewritten completely, and to keep the same functionality or improve functionality, but reduce the overhead a lot. And with every exercise that we've done, like we've managed to scale more and more time after time. So these are kind of the orchestrator, low to no code, is very interesting in that aspect because it allows you to be more agile when you're editing code and trying to modify it while the system is working versus let's say like an API based on microservices architecture based, where you're limited more in terms of how fast you can put things up.
That's a good point. I'm also curious if you used any of these AI coding tools for code optimization, or is it still human led?
I use them a lot.
Okay.
I use GitHub Copilot extensively. I use Codex a lot as well. I like both. We have use cases for both. In terms of low to no code, in terms of the orchestrator, um, we're exploring some capabilities with coding agents in low to no code environment, like computer using agents.
Okay.
That was a fun experiment uh,
Nice.
where you can have a generative AI model um, like writing the workflow in front of you, dragging and dropping activities.
Yeah. Okay.
That was a bit fun to see. Another one we're exploring with coding agent in an orchestrator environment is having a instead of the Python activity where you write code, a Python code in it, have that be a generative AI agent that write code on your behalf, and it's fully integrated inside the orchestrator too.
I think to follow up on a couple of points Mo's made, and also something that was jogging in my mind was, we didn't just have to scale virtual task engineer, we had to scale the underlying platforms, right? So having, say Mongo Atlas and have it auto scaling, right? Where we could go up to, we started say I think we had to start at an M30. And now we're running a solid M60 all the time. To be able to scale up up and down automatically is great. But then the Ascension platform runs in a Kubernetes cluster in AWS, right? And so all of our services are Kubernetes microservices based. We've just
Mhm.
now added auto scaling to the system as well. So both from a horizontal and vertical perspective, the virtual tag engineer can scale any ways out it wants to. Right now, it's just about adding stuff, adding cases, and then refactoring code. Funny, Mo mentioned that, but one of the services that I wrote originally, I think I've refactored it probably half a dozen times, and we've only been around for 6 years. So, it just things happen, and it's a
Yeah.
great experience because once you get that code optimized, like that's like a major endorphin shot, right? You see it go,
Yeah.
you see it run, it's great. Yeah.
That's awesome. Yeah, I'm curious. What about relational databases didn't scale quite as well? Was it like the document model when it comes to MongoDB itself, or something else?
A couple things I would point out. One was it was a table design, right? It was a relational table design. So we had all the keys and stuff like that, and that was all baked in. So while that can nice and speed up queries, sometimes it didn't help us from a standpoint of the data model kept changing, right?
Mm,
So we have to refactor the whole table, rewrite the whole table. That's a pain in itself. Not really a scaling perspective, but just a pain. Uh, and then obviously with Mongo, with the JSON model, we pretty much document model. We pretty much can do whatever we want, add whatever we want, right, and refactor. From just the general scaling perspective, we just saw a lot of locking, a lot. So row locking and things like that wouldn't be released, or that we were hammering the system so hard that if the virtual tag engineer is trying to update its cache and it can't, things fail. Then you've got cases that get stuck. And one of the tenets that Mo and myself and the whole team, the whole virtual tag engineer team, really committed to, and have committed to, is no customer, no cases, black hole. Right? Nothing's left out in the void,
yeah.
because that's going to produce the ultimate bad customer experience. So I think those two things for me was the locking, the concurrency, and then the document model.
I also wanted to talk about this other aspect of scaling, right? It's not limited to your infrastructure. The accuracy and quality of the responses from your applications need to scale as well. From a user's point of view, I think this starts becoming more important, where they consistently expect um, accurate responses from you, even as they are throwing like these weird curveballs at your system, in your case, by asking weird support questions, I guess. Yeah, on that note, what does your observability and monitoring infrastructure look like to just track like uh, what the common problems with the system are, or identifying patterns for where the system is consistently struggling with certain types of things?
So traditionally, we would use something like Splunk. So we would have multiple machine learning models running in the backend, and we would record the answers of those machine learning models, the probability. We would also monitor the humans that were doing man in the middle and the human oversight, which we also had for like since 2019. We had that concept of human in the middle. So at a certain threshold, the system decides, oh, I'm 80% sure this is the right action I want to do. I want a human to look at what I'm doing. And we would look at and see, well, what did the system say? Did the human agree with it or not? And we would monitor these responses to say, all right, you know what, this answer needs to be modified. We need to have more data in here. We need to introduce more samples in the data set. Now, in the generative AI world, we still have human in the middle, and we use Langsmith um, for observability. So where we're recording the traces and we monitor and see what was done. We still use Splunk to monitor and record the human actions. Instead of now looking at how much the person, or if the person agree with the answer or not, we monitor, well, what did the system say its probability was? How did it, what did it explain, and what reasoning it gave for that answer? How much of the generated text that was submitted to the human oversight engineer was accepted? Did the human oversight accept 100% of the text that was generated? Or did they accept 50%? Or they accept none of it? So we keep an eye on those types of metrics. we we track, areas where, oh, this area is actually a place where we need improvement. We're escalating too much here. So we need to look there. Are there tools failures in the background? Do we have a knowledge gap that we need to introduce? Do we need to introduce new actions or new tools to the model in that area? But also, we look at areas where we're doing extremely well, where 98% of the text is accepted, and we're like prioritizing them for more autonomy. It's like this area, this technology is doing really well. Humans like the answers a lot. They agree with it 98% of the time. Maybe it's a good opportunity to let the system, be more autonomous, think more
I
like
really like that.
Tesla self-driving type
Yeah.
thing.
Yeah.
That
Yeah.
full FSD, that's what kind of areas where we think that the system can actually run fully autonomous on its own. So yeah, that's kind of how we do primarily our observability stack.
I really like that. I did. I had a hunch that you might be looking at the data and doing error analysis, but I like this process of like using that to increase your confidence in the system itself. I love that. Do you want to touch more about like your approach to handling that long tail of unique user problems? I think this goes back to something you said before about like no two users are the same, right? So yeah, like even if your system has like a huge body of knowledge, you're going to be seeing new questions all the time. So how does the system kind of, yeah, handle that long tail of unique user problems?
Yeah, I mean, what we're going with in terms of generative AI, there are two main architectures that we see today. There is a flexible uh, agent architectures, and there are restricted agent architectures. The restricted agent architectures are more like I want to control what the agent is doing. I want to drive the agent in a predetermined path and have it do decision making in some areas. But a lot of areas, it's primarily written by code and handled deterministically because I want to have more control over what the agent is doing. The flexible agent is the architecture that we're going with. And it's pretty much saying, well, we want the agent to be able to determine on its own and the plan of execution, right? And because of this flexible architecture, um, the agent can handle a lot of different scenarios as they come in. The other benefit from this architecture is um, when you upgrade the model, when we get newer models, right? All what you have to do, you won't have to re-architect your system, right? All what you have to do is just update the model in your agent. And by doing so, your entire system becomes like 10 times smarter. Um, so that's what we've been observing as well.
The agent comes up with some answer. Do you basically forward all the agent's answers to the system, or is there some like human in the loop or some automated thresholding there to say only if the agent is, I don't know, 80% confident in its answer are we going to forward this to the user, you know?
This is an area where we're looking heavily into right now. The
Okay.
majority of the answers that we provide are looked up by humans.
Okay.
We monitor the performance. There is one problem space that we have the system running in full autonomy, um, and it's been doing very well. Customers have been happy with its responses. Uh, there are several candidates of other problem areas where we think the agent can run fully autonomous. And when I say fully autonomous, it means that it can decide, we can let it decide on its own when it's, happy with the answer, or versus when it's going to say, oh, I need a human to come and hold my hand for this one. Uh, so that's kind of what we're looking for. But it's I think pretty soon, around in this quarter, we're gonna expand more on autonomy for it. We feel like the current set of models and probably the next generation GPT-5 models are gonna allow us to do more autonomy and more autonomous answers and actions.
Since you already started talking a little bit about what's important for you in the next quarter, I wanted to, I guess that's a nice note for us to end on. So, what are some possible, challenges, issues when it comes to like ethical considerations or guardrails that you see with this system, right? It's something that talks to humans all the time. You are putting a lot of trust in its responses. So, um, do you have anything on the horizon that goes deeper on this aspect of it?
Well, at a high level, we really do have to consider ethics. Cisco has its own internal review board. For anything that is generative AI driven, generative AI based, right? So we take that with the utmost concern, both from security standpoint and from just generally a human to human or human to machine standpoint. We do put some things in place, which we'll talk about here in a moment, but we have everything that's reviewed again across Cisco. It's very consistent with the review boards as well. But it's also a fact of us being able to go and show to the TAC engineers, right, that hey, this is really producing good content that the customers will benefit from, and it'll help their job because. Part of that ethics underlying piece is also got to be adoption, right? If even if we build the greatest system, if you don't have adoption of users and they don't believe in it, then it's going to flounder. And I think that's something that the team as a whole, attacked, especially when generative AI was first coming on board, and making sure that when we do send content, we notate it that it's been generative AI delivered or generated, so customers are aware. We don't want to pull the wool over anyone's eyes.
Some of the stuff that we're also considering is we're considering to use um, Cisco AI Defense for guardrails inside our solution. And Cisco AI Defense is pretty much will allow us to kind of catch problems in the input to the LLM and in the output of the LLM. So allows us to help with that type of autonomy and help us drive it forward. Again, more the system actually overlooking and overseeing itself and figuring out if it's doing the right thing, saying the right thing, not just technically, but also like in terms of violating some of our policies when communicating with customers. So that's going to help us a lot. And this is a this is gonna be a wild ride, I would say, because I think it's gonna be really interesting to see how it's gonna work. But I'm sure we're gonna hit some bumps in the way. But I'm certain, like we're a great team. Shawn is a great mentor of mine, so we're probably gonna get over them.
I love that. That's such a great note to end on. Just that I trust my team to like go do something awesome. So
Yeah.
that's great. Well, thank you so much for being here today. I didn't even realize how this episode went by, which means we had a good time. So thank you so much.
Yeah, it was a pleasure being here. I have a couple little quickies to end us with, or at least a couple things that I wanted so one, and I think one of the tenets that the team really relies on, and I think you've heard it in this podcast, is we use the best tools that we can put together. Right, we build a really complete tool belt. So you've heard Splunk and Mongo and Ascension, all these things. So we don't just rely on one thing to do everything. And I know Mo and I have mentioned team quite a bit, so I'd be remiss in saying that Mo and I are two members of an amazing virtual TAC engineer team. That team consists of ourselves, David White Jr., Felipe DeMello, Dion Pillsbury, Magnus Mortensen, and Kevin McCabe, who are all amazing engineers in CX and Cisco. So just shout out to them. Hopefully they're watching this.
I hope so. Thank you so much. That was great.